you warned us about this storm.
Yeah.
I think some people were surprised at sort of the strength and the wind speed and everything else. So
yeah.
what happened? How did that shake out that way?
So there's a term being thrown out a lot online today called the Fujiwhara Effect, which is a phenomenon we observed as the storm was rapidly strengthening, which as we step over to the video wall to talk about kind of the big picture perspective, it not only refers to that phenomenon, but it also informs why the storm evolved just a little bit differently. Now, where the storm is at the moment, we've got the big center of low pressure outlined on the map here, and this is typically how we refer to these systems as one area of low pressure, meaning less atmosphere here, all the air rushes in from outside to replace a relative vacuum. But when the storm is intensifying, as the storm did today, it's more complex. There are little areas of low pressure that are competing for dominance as the storm is getting its act together, and how those lows interact with each other, that's what the Fujiwhara effect refers to. It was discovered over 100 years ago by a Japanese meteorologist observing tropical cyclones, but you can see it on a smaller scale. This is the radar loop that I tweeted out about noon today as one of those smaller lows was headed for the Santa Cruz County coast. And this produced widespread damage within Santa Cruz County with those gusty winds associated with that smaller area of low pressure. Now, it looks like this is orbiting around kind of the parent low, like a planet orbits around a star. But actually, these interact with each other more like a binary star system where those two stars rotate around a common shared center of gravity. So these are actually impacting each other. This smaller, weaker area of low pressure was able to drag the parent storm system a little bit farther to the north. So instead of the storm intensifying farther down the coast towards Big Sur, it really rapidly intensified almost directly over the Bay Area, which is why we had such a high impact from this storm system across the entire region. Now, this is something we see on all scales in the atmosphere. We see it within tornadoes, with these little suction vortices within a large tornado swirling around and interacting with each other following that Fujiwhara effect. We see it within the eye of a well-developed hurricane, little what we call mesovortices spinning around within the eye itself. We see it even with hurricanes themselves, or tropical cyclones. These are cyclones in the southern hemisphere, which is why they're spinning the opposite way, interacting with each other and affecting how the other evolves. That's the kind of thing that we were observing in the atmosphere off the coast of the Bay Area. Not something that we typically talk about, but it resulted in a much more intense system, both in terms of wind and in terms of the rain that continues to fall across so much of the Bay Area. We're going to zoom in for a closer look at First Alert Doppler coming up in a few minutes, show you some of the flood advisories and warnings that are in effect, and take a look at when this is going to settle down.
Yeah, a lot of us looking forward to that. And, you know, speaking of warnings and watches, there is a lesson tonight about why those are so important because of just how dangerous this weather could be. The winds were so powerful today, they actually caused 2 deadly freak accidents when falling.
And it's not just us. We've been talking about the blizzard warning in Southern California and winter storm warnings in the Sierra. Let's switch over to the weather maps and take a look at the big perspective here. And I've just turned on all of the warnings so you can get just a sense of how widespread this wintry weather is. It's actually different pieces of the larger parent storm system kind of getting spit out over the Great Plains. But we have winter storm warnings, blizzard warnings, wind advisory, winter storm watches, winter weather advisories, high wind warnings, wind chill advisories in effect. All of this is just going to continue making its way to the east. But let's talk about what's going to happen around here. The next heart of this little storm system, kind of spokes around a wheel, is going to be dropping down towards it. It's an area of low pressure in the upper levels of the atmosphere. It's associated with very cold air, and it is dropping down towards us. That's going to squeeze the atmosphere. It's going to tap into more moisture and send that towards us in the form of rain, and at the higher elevations, some snow. So let's talk more about that particular perspective, because this is a rare event for the Bay Area when we're talking about those snow levels dropping down from just beyond the peaks. I want to bring in our augmented reality graphics. And Darren talked yesterday about how the snow level is going to vary on Mount Diablo. I want to talk about the Bay Area just in general, because we have such varying geography, and it makes a difference. What a lot of people don't realize is that the precipitation that falls across North America largely forms as snow, even in the summertime. High up in the atmosphere, it is cold up there. Now, in the wintertime, that cold air gets a little bit deeper and it drops down towards about the level of the peaks around the Bay Area, roughly to 3,000 or 4,000 feet. But for the rest of us, there's plenty of warm or at least mild air between that and ground level for all that snow to melt before it reaches the ground. The difference is this heart of the storm system moves in overhead. It's got a lot of cold air associated with it in the upper levels of the atmosphere, and some of that cold air is going to drop much, much closer to ground level, and that pushes the snow farther down from the peaks closer and closer to sea level, but not all the way towards sea level, because the flow of air off the Pacific Ocean is going to keep temperatures in the lowest at least 500, more likely 1,000 feet in the atmosphere, substantially above freezing. That means the snow is going to melt before it reaches ground level, but it's just something we don't see all that often. Now, the amount of snow that adds up is really going to vary kind of based on your specific elevation, and it has to do with how the difference is between 1 inch of water and how much snow that adds up to, what we call the liquid to snow ratio. You get the temperature a couple degrees above freezing, and it's only going to add up to about 5 inches of snow. The higher elevations of the Bay Area, temperature drops below freezing. It adds up to about 10 inches of snow for the same amount of water, but we don't see those snowfall ratios like they do in the High Sierra, where 1 inch of water is equivalent to 20 inches of snow. So the closer you are to that dividing line between rain and snow, around 1,500 feet in elevation by Friday morning, you're going to get that very thick, wet snow that mostly melts on impact. We're seeing some of that on the radar already. Some of that's been flying through the Santa Clara Hills, the Santa Cruz Mountains. This is going to be sporadic shower activity as we head through the rest of tonight and through most of the day on Thursday. The showers are going to be more mist than hit, but as the heart of that storm system drops down towards us, it's going to find more moisture and send it into the Bay Area, largely after rush hour Thursday evening. And you can see for most of us, we're living in the lower elevations. It's going to be mostly rain. If we're going to see that snow level creeping down just a little bit farther than expected, it's likely going to be in the early hours of Friday morning, but I think the lowest it's going to get is around 1,000 feet. Still plenty of rain to mess up the Friday morning commute. We're going to be seeing that continuing to rotate through as we head through the rest of Friday. And that does look like we're going to see some lingering showers trying to back up towards us late Friday night into early Saturday. That activity should diminish by Saturday afternoon. So enough snow to mess up conditions on Highway 35, Highway 17, Highway 9 through the Santa Cruz Mountains. Same thing if you're going to be trying to take advantage of the snow near Mount Hamilton on California 130. That is going to be almost impassable. Near the level of the Caldecott Tunnel, I think there might be a layer of flakes, but it's not going to be a substantial amount of snow at that elevation. Of course, the North Bay Mountains are going to pick up quite a bit more snow as well as you climb higher and higher up in elevation. For most of us, we're talking about a half an inch to an inch of total rainfall, and that's enough to make a difference in terms of the long-term drought conditions across the Bay Area. Of course, the higher up you go, that's going to be converted into snow. And it's going to be cold out there, too. Temperatures starting off in the 30s area-wide tomorrow morning. Even San Francisco starting off in the upper 30s early Thursday. And we only warm up to the upper 40s to around 50 degrees for highs tomorrow before that rain and the higher elevation snow moves in.
And I know it's hard to tell, so you can tell whether or not there's going to be fog, but how high it'll be is a little different story,
That's the big wild card, and I'm optimistic that it'll be a better display than last year when you really couldn't see anything.
Nothing.
But the fog and low cloud cover is definitely out there. So let's take a look at the hour-by-hour forecast as we head through the rest of this evening. Temperatures are going to be in the 50s, so you want to layer up appropriately. And the low cloud cover and fog is going to be a factor. How much of a factor depends on how high off the ground that fog is. And for some perspective on that, I want to bring in our augmented reality elements, specifically the Golden Gate Bridge, because the tower of the Golden Gate Bridge brings in a good benchmark for whether or not the fireworks are going to be visible. The top of that tower is just under 750 feet above water level. Most fireworks burst at a range of 600 to 1,200 feet, depending on the size of the shell. The bigger ones burst higher up in the air. So if we had the same weather pattern that we had late last week and over the weekend, with the big heat dome in place over the Bay Area, strong area of high pressure, it just means there's more atmosphere on top of it. That really compressed the marine layer down towards ground level. Thick fog at ground level, but it was a relatively shallow layer of fog. Nonetheless, if we had those conditions this evening, the fireworks would mostly burst above that and you wouldn't be able to see much of anything. This is the kind of weather we had last year on the 4th of July. What we've seen happen over the past couple of days is that heat dome weakened a relative area of low pressure in the atmosphere, less atmosphere on top of us, and that allows the marine layer to get much, much deeper. So the fog isn't quite as dense, and it forms with its base farther off of ground level, as opposed to actual fog. It's more low cloud cover. So depending on exactly where that base decides to set up, we may see kind of a mix of some of the smaller shells bursting below the base of the clouds, some of the larger ones bursting within the clouds, the colorful fog display that we're used to in San Francisco. It's a long way of saying that it could go either way, but some signs of cautious optimism that maybe we are going to be able to see at least part of the fireworks display at Fisherman's Wharf. I want to take a live look right now at the Golden Gate Bridge. And again, we can see the top of the tower, and that's why we are still cautiously optimistic that a couple hours from now that fog won't have dropped down to a level that would obscure the majority of the display. So let's talk about El Nino, because it looks increasingly likely that El Nino is going to have a huge impact, not just on our weather in the Bay Area, but across California and around the entire world later this year and into 2024. But first, since it's been 8 years since the last El Nino event, let's do a little refresher on the science of this, exactly what it is. It's something that does have an impact on weather across the entire country, but it's something that actually occurs thousands of miles away in the equatorial Pacific. It has to do with sea surface temperatures. So let's set up what usually happens. The normal state of affairs is that the trade winds, which blow from east to west, take the warm ocean water near the equator and push it into the western Pacific. What that allows is for cooler water to float from underneath and replace it off the coast of South America. It's called upwelling. So usually the temperatures off the coast of South America are quite cold, and the temperatures in the western Pacific are very warm. Now, during an El Nino event, the trade winds either weaken or even reverse. And so it's like tilting a bathtub where all of that warm water that's usually packed up near Australia and Indonesia floods across to the other side of the Pacific Ocean. It pushes that cold water farther down in the eastern Pacific, and we get this abnormally warm patch of water off the coast of South America. The problem is that while that is a sea surface temperature phenomenon, it has a big impact on the weather patterns in the atmosphere above ocean level, and it actually has a downstream effect, not just locally, but around the entire world. Now, we're already starting to see the signs that this is beginning to develop. We're going to bring in our virtual Earth here and take a look at the sea surface temperature anomaly map. So we're tracking how far above or below average current ocean temperatures are, and you can see that bright blob that is just off the coast of South America already. Even though we're not into the peak of the time of year when El Nino usually occurs, which is usually during the wintertime months, we're already seeing that patch of warm water showing up, and you can see the trail that leads back into the western side of the Pacific. All that water is flooding across in the opposite direction that it usually does. So we're not into officially El Nino status yet. That takes a little bit of time to evaluate, and according to the latest data from NOAA, they estimate about a 40% chance that we are actually going to be in El Nino conditions once they tabulate the data from April, May, and June. We take this in 3-month increments, so you see the AMJ standing for April, May, and June. You're going to see more of those abbreviations as we take a look at the probabilities as we go farther into 2023, because those probabilities are going to increase dramatically. By the time we get towards late summer or early fall, we're looking at an over 90% probability that we are going to be in an El Nino event, and over a 50% chance that it's going to be a strong El Nino event. That's something that we've seen recently. The last El Nino that occurred in the winter of 2015-2016 also was categorized as a strong El Nino event, and that means that the impacts that it has are going to be that much more dramatic across the entire world. Just the air quality is still a concern. Here's a look at the current air quality map. And again, these are the purple air sensors, not the official EPA sensors. There are just way more of these and they update more frequently, so it gives us a better sense of what's happening right now. And you can see where the worst air quality is clustered, really right around Livermore, much of the East Bay and the Santa Clara Valley in that orange to even red category, unhealthy air quality levels. While elsewhere, green and yellow kind of jumbled together, either good or moderate air quality readings. Now, we are going to get some rain as we head through the weekend. Let's take a look at how much we expect. And while the numbers in the circles represent how much we exactly expect, I want to focus on a few locations, beginning with San Jose. The text underneath the city of San Jose there shows boom and bust. This is how we talk about snow forecasts in other parts of the country, but it's useful for evaluating rain forecasts around the Bay Area because it gives you the range of possibilities. If we hit the jackpot, San Jose could pick up 3 inches of rain Sunday through Thursday by the time things wind down. If everything comes up snake eyes, we're talking about a ½ inch of rain. And it's a similar range of possibilities for other parts of the Bay Area. I want to take a look at Concord, where we're forecasting 2 inches of total rainfall. The boom amount is over 3 inches, but the bust amount is less than 1 inch of rain. So you can see there's still some uncertainty. San Francisco's likely to get more rain than that, forecasting an amount around 3 inches. But the boom amount, the jackpot amount, is about 4.5 inches of rain. Even the bust amount is about 1.5 inches of rain. So likely to see a good wetting rainfall for the entire Bay Area. It's just a matter of exactly how much. Higher amounts for the North Bay. One more spot to focus on, looking at Santa Rosa, where we're forecasting about 3.5 inches of rain, but things could easily overachieve and pick up close to 6 inches of rain And even if you miss out on the heaviest bands, we're still talking about 2 inches of total rainfall. And this is something that we definitely do need. This is going to be an atmospheric river, but a beneficial one because we're running a significant rainfall deficit so far in the water year. Since October 1st, less than 50% of our average rainfall has occurred so far. We're going to put a good dent in that rainfall deficit as we head through the next several days. I'll be tracking it hour by hour coming up in the full forecast.